Hello guys, Kinan here. Today I'm going to show you how to inverse kinematics. For those of you who don't know, it's like, let's say you got two segments here. You got the join in the middle, and basically wherever you move the second part, it reaches the position like with a certain angle. So one day I was playing around and I found this weird way, I guess, of doing it. Let's get started. What we're first gonna do is insert these two parts, which I already did. So this is the start and this is the end, and we're gonna go insert a script, and we're gonna make variables for the part 1 and part 2. So game.workspace.p1, game.workspace.p2. Okay, so next, for those of you who don't know, the formula for the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. So this finds the midpoint formula, which in this case should be about here. So let's just do that really quick. So local joint equal, I'm gonna call it joint on that position plus p2 that position divided by n joint equal joint divided by 2. So this is our midpoint position, or we can call it joint now, I guess. So what we're gonna do next is we're gonna get the distance between part 1 and part 2, my bad, sorry, and we're gonna divide by 2 because that will be the distance between this point and the joint. So let's do local distance equal to p1 dot position minus p2 dot position dot magnitude divided by 2. Okay, so and we're gonna do local segment 1 equal to, let's say, let's just copy this part. So p1 clone segment, or we can do an instance on it so we can change colors however we want. Part game.workspace and segment that one anchored equal to true, segment that one can collide, let's make it to false, and let's see, we want to make it a certain color. Let's see, we can make it let's do it I don't know, brown, I guess. So segment 1 dot or let's just put blue, some sort, yeah, let's put that. Segment dot brick color equal brick dot color dot new, and let's put pastel blue. Okay, so segment 1 dot size equal to let's see how fat the segment is gonna be, like the diameter, or I don't know how to say this. So let's just do it like vector 3 dot new 7.7, and let's put the distance and name the segment 1. So local segment 2 equals segment 1 clone, segment 2 dot parent equal game dot workspace. So what's next is we're gonna create a array function that like makes the segment looks from one point to another and doesn't change the size. So function array segment point 1 point 2 segment dot cframe equals cframe dot new p1 p2. So this makes it this makes it go to this part and looks at that, and look at that way. But well, what it's we still have to do something because it will be in the center, and we want the end of the segment to go in the center of this and look at that. So then we just do times cframe dot new, dot new 0 0, And since we're changing the size of the z-axis, which is here, we're gonna also put it here, which is negative distance divided by 2. So let's give it a shot and raise segment segment 1 p1 dot position joint, and let's copy this and just change segment 2, make this joint, and p2 dot position. So let's give it a test and see what happens. I don't know why it's taking so long. Let me just pause this and I'm gonna play it back one. Okay, so it loaded up and this is what we got. And I don't know why this changed, so let's go. Oh, it's because we changed the color here, so okay. And so yeah, what we're gonna do next is we're gonna find the endpoints of a segment. And what I mean by that is, let's say we got this part here, and we're gonna get, let's say, if the part is rotated, let's say like this or somehow, and we're gonna get the position of this endpoint and this endpoint, and we're gonna get the closest one to a certain point. So let's just delete that and let's create the function. So find endpoint segment closest. Let me just make this bigger. So okay, and we're gonna do now, since we're changing the size of the z-axis, we're gonna do local point 1 equal to segment dot position plus vector 3 dot new 0 0, and for the z-axis we do segment dot size dot z divided by 2, and we basically copy this, make it 0.2, and just so first it goes on this side then the other side. And what we're gonna do next is local c-frame 1. Now we get the rotated c-frame, like if the segment is rotated we get the exact position of the endpoint. So we basically find the angle of the segment, which is local angle xyz equals segment dot c-frame to your angles xyz. Okay, so this basically turns into radians, so we don't need to like put the math.rad. So local angle equals c-frame dot angles xyz. Okay, so then we basically, so the center of the where we want to start is the segment position. So segment dot c-frame times angle times, we're gonna do segment dot c-frame inverse times c-frame dot new and we put p1 there. So this will be the position for the first part, and let's name it cf2. So we basically got a rotated part. Now what we have to do next is find the closest one to the point, which I'm gonna rename here point. And let's see, local mag1 equal to cf1 minus point dot magnitude, local mag2 equal cf2, and I forgot to change this, so cf2 0.2, okay, cf2 minus point dot magnitude Okay, now what we're gonna do is we're gonna find the closest one, the lowest number. So if mag1 is lower than mag2, then so this means this is lower, and we're gonna return this point. Return cf1, else return cf2. So we got most of it done, and what we're gonna do next is just do the to solve it, which is gonna be in the next part. So just watch the next part, and yeah, you're gonna see how you can solve this. Thank you for watching, and go to the next video to find more about inverse kinematics.